Macro-scale setup and climatological context. We are late in the Atlantic hurricane season, and the Southeast is in a transitional regime. Troughs over the eastern U.S. ridging offshore and tropical disturbances trying to organize in the Atlantic/Caribbean. For Georgia and the Carolinas, the region sits on the backside of a mid-level trough currently anchored over the Carolinas. That places much of Georgia in a subsidence regime aloft today, with relatively dry mid-levels and weak forcing for ascent. Per the Atlanta/FFCAFD, over South Florida, we are beneath weak steering flow and largely light synoptic pressure gradients. High pressure over the eastern Gulf maintains light winds, allowing mesoscale processes, sea breezes, local boundaries, to dominate convective initiation. Meanwhile, Tropical Depression 9, soon to be Imelda, is located near the Bahamas. Its influence is modest today, but will begin to nudge moisture east-west gradients and subtle low-level pressure gradients as it tracks northward. From FFCAFD short-term discussion. This is a classic late-season pattern. The interior and higher latitudes are under the influence of mid-level troughing and subsidence tendencies, limiting deep convection, whereas Florida more directly feels the moist tropical air mass and boundary-driven forcing. Florida: moisture, instability, storm motion. Moisture profile and instability. The 12Z sounding at Miami, KMFL, shows precipitable water, PWAT, near 2.05 in. Deep tropical moisture is firmly in place. CAPI, convective available potential energy, is strong. Forecast soundings suggest 4,000 to 4,500 joules per kilogram, even though lapse rates in the lower to mid levels are modest. 5.4 to 5.6 degrees Celsius per kilometer. DCAPE values, a proxy for downward momentum, are in the 600 to 800 joules per kilogram range, supporting the possibility that strong downdrafts could produce gusty wind cores and storms. With abundant moisture, heavy rainfall is possible, particularly given slow storm motion. Storms may repeatedly traverse or linger over areas. From MFLAFD update. Convective initiation and steering. With weak synoptic flow, sea breeze convergence, and mesoscale boundaries will serve as the primary triggers for convection. The eastern and western sea breezes will push inland and collide with interior convergent zones. Once storms initiate, their motion will be slow, largely under the control of local inflow, outflow, boundary propagation, and weak mid-level winds. Some drift back toward the east coast is expected during the afternoon. The slow propagation means heavy downpours and localized flooding are possible, especially in metro zones with poor drainage. Wind gusts of 45 to 55 miles per hour in stronger cores aren't out of the question, driven by downdraft momentum and steep low-level lapse rates. Spatial focus and timing. The strongest convective coverage is expected in interior zones, but storms can return toward the coastline in the late afternoon. Peak thunderstorm activity will likely occur mid to late afternoon, subsiding in the evening. Overnight, scattered showers may linger near the coast, but most areas should quiet down. Aviation impacts and warnings. Expect erratic, gusty winds near convective cores and brief reductions in visibility and ceilings, sub-VFR, near heavy downpours. Terminals along the East Coast should watch for short-fused AMDS as storms drift back toward them in late afternoon. Marine zones. Seas remain modest. Atlantic approximately 2 feet or less. Gulf approximately 1 foot. but thunderstorms may locally enhance winds and seas near convection. Expect a highly moist atmosphere primed for convection. Storms will mostly start via sea breeze collisions and other local boundaries. And because upper level steering is weak, these cells may meander slowly. This slow propagation increases your exposure to heavy rain cores, gusty outflow winds, and turbulence. If you're operating toward coastal terminals mid to late afternoon, watch for convection drifting back toward the coast. AMDS or short fuse advisories may be necessary. Forecasters, your challenge is to track mesoscales initiation zones and cluster evolution. The deep moisture and strong cape give thunderstorms the potential to intensify quickly, so nowcasting and radar-based alerts are key. Monitor low-level moisture convergence lines and the evolution of outflows and boundaries. In Georgia, models should remain muted. The forecast will mostly hinge on whether the easterly moisture surge from the tropical periphery can overcome subsidence and dry mid-levels.